so happy you came by. For a lesson about the essence of the iononuclei. DNA is a topic so fantastic. We're talking about the oxyribonucleic acid. Development and elements of bumblebees, talking trees with DNA's the recipe. It's only in a chromosome of the nucleus. DNA drives the much genetically controlling us. First and word infectious germs. The second that is for DNA is the information. For the life it's a molecule in charge of every cell. Oxyribonucleic acid. We're talking about the oxyribonucleic acid. Fantastic. The shape is key, probably well known to you. Double helix, twisted ladder, or a double corkscrew. Imagine a twisted length of tape with deoxyribose sugars on the edges with phosphate. Sugar phosphate, negative sides of the ladder with nitrogenous bases on the inside with the bases like the rungs. Together with deoxyribose sugar and a phosphate make a nucleotide. Deoxyribonucleotides are monomers linked together for DNA polymer 0.34 nanometers. Marks the space between one nucleotide and the next one's place. One turn takes 10 bases in a row, as you can discern. Since space between nucleotides is 0.34, one turn takes nanometers 3.4. So stylish, so slick, first described in 53 by Watson and Crick. Don't forget Franklin, she took that famous X-ray pic, but she died, so she never got a Nobel Prize. Oxyribonucleic acid. We're talking about the oxyribonucleic acid. DNA. The nitrogenous base is common one of four varieties, known by the letters A, T, C, and G. A is for adenine, thymine, got the T. C is for cytosine, guanine, got the G. A and G with two nitrogen rings of purine. C and T with one ring of pyrimidine. C only bonds with G. A only with T because like puzzle pieces, they're complementary. They fit together, snuggled up like hand and glove, like enzymes and substrates, like people and blood. A, T, C, G matched up like lock and key, forming hydrogen bonds, either two or three. Hydrogen bonds, you know they aren't very short, but they're enough to hold DNA together all day long. The way the bases fit together couldn't be sweeter. They give DNA with the 2 nanometers. DNA's double-stranded, looks pretty swell. The strand's orientation is anti-parallel, with one strand standing up, the other on its head. It's how they fit together, Cricket Watson said. DNA, fantastic, deoxyribonucleic acid. We're talking about the oxyribonucleic acid. Fantastic. Sugars and phosphates make the backbone, the structure, but the sequence of bases is where you find instructions for development of bodies in the cytoplasm that constitutes like miracle when folks are golden out. Sequence of bases is unique, a special match. Unless you're an identical twins from a match, and you can bet that if you're not Jango Fett, that you've got no clone, no one like you's been known. Our bases comprise our individuality. You might have an Abraham, a height. I have a G. Explain it why I'm bald, you got all that hair. These differences. I'm so happy you came by. For a lesson about the essence of the iononuclei. DNA is a topic so fantastic. We're talking about the oxyribonucleic acid. We're wondering about development and elements of bumblebees, talking trees while DNA's the recipe. Only in a chromosome of the nucleus. DNA drives the most genetically controlling us. First and word infectious germs, mommy's egg and daddy's sperm. DNA is the information linking up the generations. It's a code of life. Listen up well, because DNA is the molecule in charge of every cell. Oxyribonucleic acid. We're talking about the oxyribonucleic acid. The shape is key, probably well known to you. Double helix, twisted ladder, or a double corkscrew. Imagine a twisted length of tape with deoxyribose sugars on the edges with phosphate. Sugar phosphate, negative sides of the ladder with nitrogenous bases on the inside with the bases like the rungs. Together with deoxyribose sugar and a phosphate make a nucleotide. Deoxyribonucleotides are monomers linked together for the DNA polymer 0.34 nanometers. Marks the space between one nucleotide and the next one's place. One helix can make one turn, takes 10 bases in a row, as you can discern. Since space between nucleotides is 0.34, one turn takes nanometers 3.4. So stylish, so slick, first described in 53 by Watson and Crick. Don't forget Franklin, she took that famous X-ray pic, but she died, so she never got a Nobel Prize. DNA, fantastic, deoxyribonucleic acid. We're talking about the deoxyribonucleic acid. The nitrogenous base is common in one of four varieties, known by the letters A, T, C, and G. A is for adenine, thymine, got the T. C is stands for cytosine, guanine, got the G. A and G with two nitrogen rings of purine, C and T with one ring of pyrimidine. C only bonds with G, A only with T, because like puzzle pieces, they're complementary. They fit together, snuggled up like hand and glove, like enzymes and substrates, like people in love. A, T, C, G matched up like lock and key, forming hydrogen bonds, either two or three. Hydrogen bonds, you know they aren't very short, but they're enough to hold DNA together all day long. The way the bases fit together couldn't be sweeter. They give DNA with the 2 nanometers. DNA's double-stranded, looks pretty swell. The strand's orientation is anti-parallel. With one strand standing up, the other on its head. It's how they fit together, Crick Watson said. DNA, fantastic, deoxyribonucleic acid. We're talking about the deoxyribonucleic acid. Fantastic. Sugars and phosphates make the backbone, the structure, but the sequence of bases is where you find instructions for development of bodies and the cytoplasmic activity that constitutes like miracle and codes of golden algae. The sequence of bases is unique, a special batch. Unless you're an identical twin, it's nowhere matched. And you can bet that if you're not Jango Fett, you've got no clone. No one like you's been known. Our bases comprise our individuality. You might have an A where I have a G. It's red and white and bald, you got all that hair. These differences can show up anywhere. The protein hemoglobin, listen up, well, it carries oxygen in your red blood cells. Hemoglobin's made of 4 protein pieces, pretty widely shared among animal species. The base is spelled with hemoglobin B's, hundreds of A's, G's, T's, and C's. The genes start CACGTGCAC, then TGAGGACTCCTC. The key is these bases are information, but hemoglobin's function and conformation. Hundreds of bases in a predetermined order. A single change brings on a major disorder. Change T to A in one single spot. This little point mutation might not seem like a lot. Thymine to adenine might not seem that big to you, but maybe that's the cause of sickle cell anemia. DNA, fantastic, deoxyribonucleic acid. We're talking about the deoxyribonucleic acid. DNA. Fantastic DNA, fantastic deoxyribonucleic acid. We're talking about the deoxyribonucleic acid. DNA, fantastic.